All right, good evening, everybody. Thank you, and welcome to the August edition of the Astro Imaging Special Interest Group from the Tucson Amateur Astronomy Association. Um, do we have any folks who are new to the group, or maybe this is your first time online with us for our monthly meeting? Please feel free to speak up and introduce yourself. I think we have mostly folks who've been here before, but I always want to make sure I didn't miss anyone. All right. No new folks, at least none that are going to admit to it. And as usual, we start off with the question answer session specifically oriented towards what we would call beginner questions. So whether you think it's a beginner question or not, if you have a question that you want to throw out to start things off, please feel free to do so before we get into the regular part of the session. Any beginner questions? No. All right. Well, we have a bunch of non-beginners here tonight then. All right.
Or people
Well,
that are just exhausted by the heat.
yeah, probably that's it.
I do
Um,
have a small announcement.
okay.
I just want to mention that coming over the next 2 months, we're going to be updating the images out at CAC that are
Oh,
shown on the
good.
TVs. And I've been working with a couple of people to put together the process. But we're kind of redoing what Doug Summers did 3 years ago or 4 years ago. It's been passed on to me to take over since Doug doesn't come out that often anymore. So I'm going to look for people that want to either update the images they have out there. I'd like to just kind of replace everything instead of piecemealing it. So it gives people a chance to go back and reprocess some of their older images with the newer tools that they might be using, or to add new images. And then for the people that don't have anything out there right now, it gives them an opportunity to add some images on the image board. So I'll send out an email looking for people to, that want to reply to being involved in it, and then I'll get the instructions out to them individually so I don't mass mail everything on everybody on the instructions, because they'll be kind of a little bit lengthy describing the process, but it'll be fairly simple. We're going to use a process where you don't really need to get your name and image name on the image itself. We'll use a file naming convention that'll automatically put that on the image for display out there. So I'm sure if you've been to CAC, you've seen the image board. It gets used when star parties are there, and then normally it's turned on during, new moon weekends, and that's what we're talking about updating. So that's my little announcement.
Good announcement.
Yeah.
Please make sure you post it on the forum too.
Yes.
The initial message.
Jeff, since we're kind of talking about CAC, would you like to jump in and discuss what you've been trying to organize?
Now, pointing the finger squarely at Jim Long, who emailed me and said, "Hey, we had that wonderful get together, except for the sky, which was terrible. Why don't we do it again?" And that was the genesis of the survey that I sent out coming up on a week ago. I think it was about a week. Um, I'll just I'll quickly share what I've learned, which is overall, I think, less excitement about the idea now than there was last spring. We have a total of 13 responses. Of the 13, 6 people have said yes, 4 more have said maybe, and 3 have said no. So I think we can let this go for a little while. I'd love to hear from folks who, if some of you have replied, what do you think? I mean, it doesn't take a large number of people to get together, especially if the skies are good. My hope would be that we could spend more time. Paul, mute for one more second. That we could spend more time looking at one another's rigs and talking about the nuances of our setups, but that requires weather that allows us to set up the rigs in the first place. So, Paul, you had a thought. Paul, did you have something that you wanted to say?
Me? I actually, I have something for Craig Harding here for his announcement you just made.
Well, hold that thought for 1 second. Let's finish this topic.
Yeah, okay.
Go back on mute.
All right. Otherwise, I don't.
Others? What do you think about a smaller group?
The dates are October 11th and 12th. Again, I think that's a Sunday and Monday, correct, Jeff?
That's right. So it's right after the new moon weekend and presumably before it gets too cold.
Yeah. Any other comments or questions about that?
You can also ping me offline.
Yeah. Seems like there was a lot of interest the last time as well. So you've got a few weeks to make up your mind before we have to commit to anything. So it'd be good to try and, do the same thing again. Even if we have bad skies, we had a good time just chewing the fat. So, okay. Any other comments or questions?
Paul, you had something about Craig's images announcement.
Yes, I have a whole bunch of them. I've been working on remastering many of my older images throughout the summer for about the past 3 months, and I have a whole bunch of them that I'd like to share actually.
All right.
So
We'll send out an announcement soon through the group.
And so okay, I guess I'll wait for you to give out the details.
Okay. Well, our main topic for this evening is focusing and auto-focusing. And since we had some advanced material over the last 2 meetings talking about the advanced sequencer in Nina, we thought it'd be a good idea to step back a bit and talk about some of the more basic stuff for some of the newer folks in the group, although I think most of the group now is getting to be a more mature group of imagers. But in any case, we thought that focusing and auto-focusing would be something that everybody could toss in their 2 cents on. So the idea here is that Jeff and I are going to kind of kick off this with a few ideas, and then it's up to you to chime in and tell us about how you focus, what type of focuser you use, what you like about it, what you don't like about it. And you don't have to participate, but this is going to be an open discussion. So hopefully some of the stuff we bring up will trigger some comments or questions from you. So I'm going to start off by sharing my screen here. See if I can get that to show up.
See the last page.
Oh. There we go. Okay, so I assume that you all know what focusing is, but in any case, I'm going to kick off this by talking about what is focusing. And I'm sure everyone here has got a clear idea of what we're going to be talking about, but in spite of the fact that it's pretty much a well-established idea that it's the idea of bringing a faraway object to focus using some sort of optics, either for an eyepiece or a sensor of some sort. There's a bunch of different ways to do it. And most of the differences in the ways we go about focusing have to do with the optical systems that we're confronted with. So you see here just something I pulled down off the web that gives you some diagrams of what the most common optical systems that I think most of us are familiar with. The top left there is the Galileo scope, which if you bought one of those back in 2010, you realized very quickly that the way you focused that was by sliding the little tube in and out. So I guess the most fundamental approach would be the refracting telescope, in which the eyepiece or the camera is moved in and out, either with a focuser or just with a sliding tube like Galileo himself used. On the top right is the good old Newtonian reflector, in which a focuser is mounted on the side of the tube and catches the focal plane as it's reflected from the main mirror off a secondary mirror. And typically these use some sort of a rack and pinion type of focuser, although other types have been used depending on what the application is, whether you're doing visual versus imaging. We'll probably get into that a little bit more. The bottom two images, the one on the left shows you the RASA type or Star Arizona type of imaging device, in which the sensor is placed at the prime focus with a series of lenses to bring things into focus. But that and the typical Schmidt-Cassegrain that you see on the bottom right both achieve focus by moving the main mirror. In the case of the Schmidt-Cassegrain, the mirror slides on a tube. In the case of the RASA, it moves by a different mechanism. But as you can see, the mechanisms for focusing differ quite a bit depending on the type of optical system that you're using. And I'm sure if you think about it, you could probably think of other optical systems that would it could be described differently, such as a folded refractor, etc. So what we're going to basically do is ask you to describe the type of system that you use and why you have picked the type of focuser and how you go about actually doing the focusing. So we're all clear on the terminology, the types of focusers. This isn't all the types, but these are some of the ones that I think you'll find commonly. The most common one, I guess, that most of us are familiar with is the good old rack and pinion focuser, as you see here on the top left, where a set of manual knobs adjust the focus tube up or down, and these are often replaced then with some sort of an electronic device. The middle image there shows the mirror moving device that you find on most Schmidt-Cassegrains or RASA type imaging devices, which causes the main mirror to move in order to achieve focus. The top right there shows a cheap electric motor which can be attached to the focuser, as you see in the middle image there. And this is kind of a poor man's way of getting focus without actually touching the focus knob. And it allows, a simple servo motor can be implemented with a battery. And this can be used for manually focusing a telescope, either rack and pinion or a Schmidt-Cassegrain type of scope, by using a simple keypad, as you see displayed there, which can move the focus motor backwards or forwards so that you can fine-tune focus in a manner that's usually better than what you can get with your big old fingers. In the bottom right there, you see a helical focuser, and these aren't used a lot in imaging, because if you plug your camera or other sensor into a helical focuser and then try to bring it into focus, you're of course rotating the field of view, and that's typically not what we want to do. However, helical focusers work really well for implementations where you want to focus a camera and then leave it in that position indefinitely, such as a guide scope, as you see in the middle slide there, or a off-axis guider where you want to bring it to focus and then keep it locked in place. So helical focusers do have their place, but they're not typically used in the main imaging train. I included the middle slide on the bottom there. That's my guide scope, and it's a little bit different than the other focusers that we've been looking at, in that there is really no guide focus mechanism. The focus mechanism is the thumb screw you see on the white extension at the left-hand part of the guide scope. You basically unscrew that and you move the main objective in and out until you reach focus at the sensor, and then you tighten that thumb screw, and that allows you to have a very rigid system where the camera itself is screwed into the back of the tube, and focus is achieved not by using some sort of a manual focuser, but by moving the objective in and out at the front of the scope. So those are just some of the different types of focusers, and I'm sure most of you are familiar with those already. We're going to talk a little bit too about electronic focusers, and I'm sure most of you who do automated imaging are using something along these lines. As you can see, there's a bunch of different styles of these. Most of them are designed with some sort of a supporting panel that can be attached to the guide mechanism or to the scope itself, so that you can attach a servo motor to the focusing mechanism, and then the servo motor is controlled by software. And so most of these devices come with the assortment of the tools that you see in the bottom right-hand corner there, including those little drums that can be used to attach the servo motor to the rack and pinion focuser or to other types of focusers. They can also be used to attach to a sprocket to drive a belt. So you can use a belt type focuser if you're using a camera lens type of system for guiding or for imaging. And again, I'm sure most of you are familiar with these, and there's a lot of different types of these. They range in price from a few $100s to a few $1,000s, depending on how sophisticated you want to be. I'll just briefly mention some of the focusing aids. I'm sure, again, most of you are familiar with these. Probably the one that's most common, or fairly common, is the Bahtinov mask, which is basically a diffraction type of grating. There's all different varieties of these, but they all work in a similar fashion, and that is they create a diffraction pattern that you can observe on your sensor, and then by moving the focuser in and out, you can cause that diffraction pattern to change, so that you see in the middle diagram there both an inside and outside of focus, where the center line in this particular diffraction pattern is not lined up directly in the middle with the other diffraction patterns, but as you move the focus to the correct position, it becomes centered. And that's again shown on the enlarged image that you see in the top right. So that's an easy way to find focus, as long as you're close to focus to start with. And sometimes getting close to focus is the more difficult operation. The bottom image just shows you diffraction spikes, as you might see from a Newtonian type reflector, where the spider that supports the secondary can be used to determine when focus is achieved. Here you see a fairly close focus. If it was out of focus, those diffraction spikes would appear double. And so if you have a Newtonian reflector, it's pretty simple to pick a bright star, look at the diffraction pattern, and adjust the focus until those spikes go from 2 spikes down to 1 spike to very narrow spike. For those of you who don't have a Newtonian reflector, you can achieve the same thing by taping a couple of pieces of string across in front of your objective lens, or where the light enters your telescope, and you can get the same thing. So a poor man's way of getting focus without a Bahtinov mask and without diffraction spikes built in is to simply put 2 pieces of string crisscross across the objective lens, achieve focus, and then you can remove the string once you're pretty close to focus. So I'm going to stop there and let Jeff talk about a few other things, and then we'll open it up for discussion. It's all yours, Jeff.
Thank you. Okay, I want to go into a little bit more detail about the tools that we use. I will make 2 comments on Greg's remarks. First of all, poor man's solutions to astrophotography matters seem inapt. This is not a poor man's hobby. It makes us poor, but you don't start that way. I was also really impressed to learn that as I'm sure you all know, that the inventor of the Bahtinov mask was in fact Boris Bahtinov. But moving right along, 2 familiar autofocusers. How much do they move actually? Well, between 5,760 and 6,000 steps for 1 revolution. So give or take a rounding error, that's about 6/100ths of a degree per step. Now, what does that get you? Not a whole heck of a lot. What you have to do, if you want to dive into the details of your focus, is you got to figure out how much a step moves your rig. And there's only one way to do it. There's no formula for it. You got to measure it. Move your focuser out 1,000 or 5,000 or 50,000, whatever, an inch or so of your focuser tube moves, and then take a caliper and measure that distance and divide that distance by the number of steps that you've moved. So if you move 100 millimeters in 10,000 steps, then you are doing about 1/100th of a millimeter per step, and you can work out the math. Why do you want to know that? Every telescope has a critical focus zone, and the most important word of that phrase is the word zone. There is not one perfect point. There is a theoretical point of best focus, but there is a band on either side of that in which focus is indistinguishable from perfect. And that's the critical focus zone. Now, there's a lot of math behind that. What I have found is most of the formulas have a fudge factor in them where you put in your tolerance for a little bit of blurriness. If your eyes are no good, you can have a much bigger critical focus zone, or if you're going to rely on blur exterminator heavily. We don't need to get into the math. I've put up a graph that based on data roughly from my telescope. You see here that my critical focus zone is about 48, call it 50 microns, with a step size of 0.6 of a micron per step, which I determined by measurement. I did like 6 or 8 different trials and averaged them. It's like 0.062 something. Why is this useful? To know what your critical focus zone is. And by the way, I have an f6 or f6.3 refractor. The key thing about focus, which you know intuitively, is the faster the system, the narrower the focus range. So my telescope tends to move only 50 or 60 steps in an entire night as temperature changes. So what this graph actually tells you is I could, in theory, never refocus my telescope during an average night, and I would be fine. I still do because of OCD, but a scope like mine is pretty flexible. You take a scope like an F10 scope, it's even more flexible than that. But if you do a RASA or a Hyperstar, you're going to have a much narrower critical focus zone. And here's a little graph that depicts it. In essence, when you have a very fast system, the light rays are coming into the focus point at a very steep angle. What that means is they come into focus at the very last moment, and then they go out of focus at a very steep angle. Compare the slope of these lines to this one with an F10 system, where the light rays come in, sorry about that, come in at a much shallower angle. And so you have a lot more range. The idea here is that the yellow range represents the critical focus zone. So if you're running a RASA, you might refocus your telescope multiple times an hour if you're really obsessive about it, because the slightest move is going to throw the focus off. As you saw with my telescope or with something even slower, you've got a lot more latitude. This is useful too, that knowing your critical focus zone is useful for setting your refocus expectations during the night, but also for optimizing the autofocus step size in your software, be it Nina, the Air, or something else. Your autofocuser, it's depicted here, as you know, takes a series of images at different steps. In this graph, the step size is 50. Ideally, now it's going to graph the hyperbola based on the data, but ideally, you want to have one of those data points inside the critical focus zone. You will get a better curve than if you were using, say, in this graph, steps of 100. So you have an image here, an image here, an image here, and an image here, and then you're relying entirely on the software to interpolate this point. So having your step size be equal to or less than your CFC, and at 48 microns, at 0.62 microns per step gives me about 70-ish, 77 steps. So if I have 50 steps or 60 steps, one of these is certain to fall within my CFC. You could do a whole topic on how you configure an autofocuser. The bad news is ChatGPT cannot tell you what the right number is for step size. You got to figure it out based on your system. The good news, it is not hard to figure out what these numbers are. You can take a few snapshots. You want to see an appreciable change in diameter, but not going from tight stars to completely out of focus in one step. What's appreciable? Just use that word qualitatively and experiment. Now, for the ASI Air, there are two criteria that I found. The first is you want a long enough exposure to get plenty of visible and stable stars. Watch the shape of the curve. If the curve is very shallow and is taking a long time, increase your step size. If the curve is steep and goes very fast, like a comet orbit around the sun, then your step size is too high and reduce it. I have listed, and we'll post the slides later, a couple of good resources online for the Air and for Nina. Patriot Astro and Quiv both have terrific guides to configuring your autofocuser. A word about backlash in the air, it's not an issue because the system either takes it out automatically or something. They must take it out automatically. Because unless you're doing manual autofocus, you have no opportunity to adjust your backlash. If you're in Nina, a good rule of thumb is whatever your step size is, set your backlash at 5 to 6 times your step size, and then you should always set it that there's an overshoot. You always want the overshoot to be going against gravity. So typically that means coming back in toward the objective each time so that you don't get a sag from the little imperfections in the gears. So that is just between the two of us an overview on the how and the why of autofocusing. And we wanted to throw it open, not just to how you do it, but what challenges have you faced and overcome?
So Jeff, I'd like to start out with a question for you. Can you go back to the slide you had of the critical focus zone?
Sure, one sec.
Please, thank you.
Okay.
Now, the one that's got the graph with the curve. Wait.
This one.
All right, so I see that you've got the best focus is sub 1 HFR.
That's made up.
Okay, that's not realistic because the best I've ever seen on my ASI Air is 1.75. I think that's the absolute best star size I've ever seen. It's typically in the 2 range. So that's my question is that normal or am I just out of focus?
It totally depends on your telescope.
Well, it's a lens and it's the same lens that Craig has. It's f2. And I'm probably shooting at f2.8 because I've got a mask on it. But I don't have any difficulty coming to the curve and finding the right focal point, and the stars seem to be under 2. So I've marked that as a success. I don't know if that is success because I really don't have anything to compare it to.
So the theoretical answer is the bigger the telescope, the tighter the HFR can be. Of course, you've got seeing and atmospheric conditions to deal with, but in theory, bigger objective means better HFR. Now, when you told me you were getting 1.7, I thought that's interesting because I've got a 4-inch objective, and that's about the best I've ever gotten.
Yeah.
Which actually makes me question.
Well, it may not be correct, and that's why I'm throwing it out there. It's like, what should I look for or try to get? I mean, where should I try to achieve? What's acceptable? I mean, my stars don't look like pinpoints; they look like round blobs. But at f2, I'm getting a lot of saturation, so I just don't know.
Craig, can you chime in since you've got the same lens?
Well, there was a couple of things going on there. Last thing you were mentioning was what your stars look like, and at that 135 Rokinon or Samyang, your stars are pretty small. And I don't know if you're putting the 294 behind that or something else, but they just end up being dots. I mean, sometimes I end up with stars that I'm like, okay, that's a couple pixels. That they're so small in that. So there's that. The other thing is, and I don't know if this really answers part of Jim's question, but it was about the curve, maybe more than anything. I don't know that I've really seen below 2, low 2s for my focusing. I don't really pay attention to it that closely. Uh, but the curve, Jeff, you were talking about either too sharp or too shallow of a curve. Um, when I'm at about 2 for the focus point, I want my curve to start at about 6 or 7. And that gives you kind of a curve more like what you're showing here, not too sharp, not too shallow. Uh, so with the Jim with the 135, yeah, the bigger problem is just getting big enough stars to do a proper focus. And when you're using the ASI Air, I don't know what you don't have any control over what star size should be that's being used for focusing.
Got it. Okay, thank you. And
I think
I have,
Nina does, if I remember right, Jeff? You can identify the minimum in the guiding. You can identify the minimum size pixels for a star to be
Yes.
used and the maximum.
I think I'm not sure if you can in the regular Nina focuser, but in Hocus Focus you can.
Yeah.
And Jim, I should add, this image is not from my telescope. I just described this to ChatGPT, and I didn't even pay attention to the HFR scale on the left. I was worried about the x-axis, not the y.
well, what I routinely do once I've gotten the autofocus routine and it picks a point is I'll go take another image and then I'll do the detect function that shows you the different HFRs of all the stars it detected. And it ranges from 2.8 down to 1.7 in that range. And I'm like, well, this is kind of interesting. I'm thinking that they're focused. And Craig, I didn't mean to say that all my stars are blobs. It's just the really bright ones end up being blobs.
Yeah, yeah.
Most of the stars are pinpoints, like they should be. I mean, I had an image of Rho Ophiuchi and Antares was this giant halo. It was like,
Well,
whoa, that's
yeah.
awful. That's terrible. And Jeff's like, that's just how it is. And the just how it is where I'm at right now, not knowing how it is. It's like, well, that's interesting. Let me bounce that off of somebody and find out if that's normal or how would you address it. And I think you told me to use Blemish Blaster to get rid of the halo, but I haven't figured that out yet, so we'll get to there.
Well, the halo
So,
is a separate issue. Even without a halo, Antares is going to be a huge disk. It's just
Yeah,
yeah.
it's huge.
it's bright and the light bleeds into adjoining pixels, and there's nothing you can do about that. I
So,
would focus on medium stars, not the faintest in the field of view. Ignore the brightest ones, but those in between stars should look tack sharp. And if they look still like circles, especially if there's a dark area in the center of them, then you
mhm.
probably aren't getting to optimal focus.
So maybe I'll share my Rho Ophiuchi image and you guys can give me a critique and say, yeah, you're not in focus, or no, that's all the bright stars are blobs because you're at F2, they're bright blobs, and that's how much you've oversaturated the stars. So just I'll do that.
Upload
Um,
it, Jim, as an attachment so we can download it. Because if you just paste the picture in, you can't zoom in on it
okay.
in
I gotta
groups.
I can. It'll be big. It's a TIFF, so you can see all the details. So
Okay.
as a related comment, Craig, when we were out there in April, we were working because we have the same lens and pretty much the same rig, we thought, and you were showing me in the ASI Air how to turn on the focus and set the steps and all that stuff. And there was a switch that said reverse. And you said, I have that checked on mine. And I said, well, let me check it and see if I can get the autofocus to work. It would not work no matter what I would do. And when I turned it off, it started to work. And what I determined was, Craig, you have a belt that goes around your lens, and
Yes.
I have a gear. And that's the difference. Mine is not reverse, yours is reverse. And that was just like, whoa, that was a revelation that I had to just do it normally and then it would work.
Well, and I think part of your issue was you were running out of you were jamming against the end of the focal
Yeah.
range.
Well,
The gears that you have were maybe the step size was a little too high, but you were pretty small step sizes. But I think what was happening is it was as it was going through the curve, when it got to the other side of the curve, it was getting to the point where there was
yeah.
no more room for your lens to turn, and it was stopping.
Well, that got fixed as soon as I turned off that reverse button. It
Yep,
would go way down in focus and then back, and it didn't hit infinity.
yep.
So that solved the problem. So that's a great segue to my next question, and this will be my last question, Jeff. I'm sorry, but um, for my lens, I can stand there and look at it and see where entirely out of focus and infinity are, and I can rotate it all the way to the point where it's totally out of focus and set that focus point as 0 and then rotate it all the way to the infinity and document what the focus point is so that I know that those are the two ends that I document as my focus point all the way out and all the way in. But on a SCT, I mean, I know you were probably talking about a refractor where you can actually get a micrometer out and measure how much you've moved
Mm.
based on the steps. But what do you do with an SCT? How do you know when the mirror is all the way out to set the 0 point, or am I backwards? Should it be all the way in to set the 0 point? The focal length gets longer as you come back towards the focuser, and shorter as you go forward towards the corrector plate. Is that correct?
What you just said is correct. You ask a
Okay.
great question, and I have zero experience with SCTs, and I don't know
On Yeah,
how
on
you
my
measure it.
SCT, I don't care. I, I I have no reason to care because I'm never going to be near either end of that.
Okay.
So I get it in focus and I just set it to like uh, within the focuser, I just say it's 10,000.
Oh, so you just
And,
arbitrarily pick a number?
I just pick a number.
Okay. All right.
And I don't care after that point because the only time I care is on my refractor when I'm putting it away. And I want to know, I set 0 to be near where it's racked all the way in. So I can
Got
just
it.
say, one of your options is to send a focuser to 0. So when I'm done, I can rack it all the way in so it fits in its case.
Ah, makes sense.
Otherwise, it really doesn't matter if you always leave your scope near focus, pick a number. And it's just gonna, whatever your step size is, it's gonna vary just slightly from that number.
Okay. That answers my question. Thank you.
Unless you're ever gonna,
I
you
have a
feel, the only
question.
time you need it is if you
Uh,
feel a need to rack it all the way in or rack it all the way out.
I have a question for Jim is what, are you using a filter?
I haven't yet, but I do have an Alpera filter. I have a Hyperstar that I want to start to use on my 11-inch SCT. I want to do some galaxy stuff and some small nebula stuff like planetaries and those kind of things. But I haven't. I was at the Grand Canyon Star Party, and as I was getting ready to pack up, I loosened the clutch and the wind caught it, and the focuser hit the leg and broke off. So I've got to go to Arizona and get all that dealt with, and I just haven't had a chance to get up there. Just pull the screws out, basically, and as I hope that's all it is. But I don't have an electronic focuser at the moment to do that. But I do have the EAF on my 135 millimeter lens, and I've learned how the autofocus routine works and kind of what the step implications are and so forth and so on. The figuring out the parameter stuff for me is the most fun of this hobby. When you've got you do the right thing and you get a success and you get a nice picture, then it's like a win.
I
Well,
have
the
a
reason
couple
I
of
ask
comments.
is, because when I first got my Rasa, I found out that a lot of my filters were no good anymore because I needed to get filters that are specific to a really high speed telescope.
Hmm.
And when, like I remember I first noticed this with shooting the horsehead, and with the star in there, just had this tremendous halo. And I switched to an NBZ filter, which is uh, uh, designed for high speed, and that problem went away.
Well, I researched that, and it came down to people talking about the Optolong L-Para and the NBZ2, and they compared the halos, and that was the comparison between the two, and they couldn't find a real appreciable difference between halo generation. They slightly leaned toward the Optolong filter. So I went to Star Zone and I talked to them. I think I talked to Steve when I was up there, but I said, "Hey, this is what they're saying on cloudy nights. What do you think?" He says, "Oh, everybody's buying this Alpera filter now. Nobody's buying those MBZs anymore." So he sold me an Alpera, and I have an Alpera which just has, I think it's got a 12 micron width. It's not a real tight one. It's not a super narrow band one, and it does hydrogen and oxygen. It's a one-shot color filter. And so I haven't used it yet. And I said to Jeff when I was getting ready to go up to Kit Peak to do all my images, "Jeff, should I take this filter and shoot Rho Ophiuchi with that filter?" And he's like, "No, not really. It's not the kind of nebula that you would benefit from." So I haven't used it yet, but I'd like to. I mean, I'm in a pretty light polluted Bortle 5 area. I'd like to do some data through the Alpera and see what it looks like because I can use that on my little 135 millimeter lens because that's also f2. That'll work on that. So I'll give it some tests, and the next time we do a talk like this, I'll give you some results.
If you're willing to stay up late into the night with Orion starting to come up in the east, there's all kinds of emission clouds around Orion. That would be a good target for that,
Cool.
and a real wide field lens. Or you got Cygnus overhead right now.
Yeah.
Of
Can I make a couple comments?
course.
Can you guys hear me okay? One is with regards to that, the question about HFR and the curve, and my audio cut out, so I apologize if I'm repeating something, but I think a lot of it depends on your pixel size and your plate scale, and if if you're binning or not. And so I personally don't think so much about the number as much as if the curve is looking like a good curve, and just allow the software to figure out the bottom of that curve. And like Jeff said, if it's shallow, maybe it's not such a good curve, or if one side doesn't really match the other very well, and it might require changing your exposure time. One of the problems with a fast system, if you're undersampling and you may saturate your pixels, and as it's trying to focus, they're going to be saturated no matter what, and you might not going to get an accurate HFR reading. So I think it's good if you can learn your system well enough to understand what stars might be providing roughly a halfway saturated photon collection, and then try to use those for focusing. And again, that's kind of ties into look for a medium brightness star, not a really bright or really faint. The second thing is on the SCT focusing, because I've been playing, or at least trying to play, with an 11-inch, and for me, where I've been like the last month, there's literally been 0 nights available to actually image. So at least I was able to collect some biases and darks. But one of the things I did was get a different type of focuser, where you lock the primary mirror and then focus it more Crayford style. And Starizone, I don't know if they still make it. They used to make a back-end focuser that was motorized, and it really wasn't for imaging, it was more for visual, and I've forgotten what it's called even. But I have one for a Meade, but for my Celestron that I'm working with, I ended up spending a little bit of money, and I got a Prima Luce Lab Isato, it's called, and it's a heavy thing, and it's got really, really small step sizes, but you basically lock it onto the back of the scope, and you lock the mirror down, and then it just drives the imaging train in and out to find the right focus. So I for a couple hours, I was able to actually test it on something, and seems to be working. But until I get some clear skies, I won't really know. But I think by locking the primary as opposed to trying to focus with the focus knob, and I know you can attach like what is it, ZWO, their electronic focuser, to that knob, and other focusers you can attach to the knob, but those are actually moving the primary, and then as the scope is tracking, your primary might flop a little bit. So it's just something to consider if you're looking at trying to focus an SCT. There's kind of 2 different versions of electronic focusers out there, and I'm not saying one is better than the other at this point because I don't have enough data to back that up, but it's something to be aware of.
Well, the problem for me would be a hyperstar. If I put the
Oh
Crayford
yeah.
style focuser on, I can't use
That,
the hyperstar anymore. And I've
so
got
that one.
an older C11 that doesn't have a mirror lock, so I'm kind of stuck. I've got to
Okay.
kind of use the mirror back and forth stuff. And at some point, I may sell that C11 and go with some kind of a refractor where I don't have that headache of mirror flop and all that stuff. And so we'll see. I bought the C11 to take images of planets, and that may be as far as I get with it. I may not get little tiny galaxies with it, which I really want to do, but so we'll see how that goes. Right now, I'm just shooting wide field nebula stuff and learning the basics, and then I'm going to switch to Nina and start doing some of the things that ASI does seamlessly, and see if I could replicate that in Nina, which seems like a daunting task. So last night, I'm taking the images of M8 and the middle of the Milky Way, and I set it to 260-second images, and that would give me 3.5 hours. And I said, that's pretty good. That's the time that between when the moon set and M8 got to the point where it was too much in the atmosphere. So I figured I had 3.5 good hours. And I fired it off about 9 p.m. and let it run. And I was using the binoculars to look for Messier objects while it was running. And finally, after I got about 60 images, I said, all right, well, I'm going to go lay down and do a Jeff Rothstein and go to sleep and let it do its thing. And I was watching the guiding and just seeing the RMS on the guiding, and all of a sudden it went up to like 15 and 16. I'm like, what the hell on RA? And I couldn't figure out what it was. And I went out and I looked, and the RA is not moving, and I just could not figure out what's going on. One of my cables snagged and got snagged in the RA drive, and I finally figured out what it was and moved that out of the way, and it actually started tracking again. But I had no idea. I couldn't figure out why the RA wasn't tracking all of a sudden, and had to put my shoes back on and go back out to where it was. So that's the danger, I suppose. I have mine focus automatically every half hour, and that seems to work pretty well for me. I don't have a temperature probe to focus by temperature. I probably should plug a temperature probe in, and maybe it would focus a little more, but what a beautiful night last night. It was 74 degrees out. It was really, really nice. Sunday this week should be like that too. So be ready. Be ready, Keith.
Now, Jim, you said something that prompts me to say something controversial.
Okay.
Nina allows you a lot of different triggers for autofocus. You can trigger on HFR change, you can trigger on time, you can trigger on temperature. And I would submit for debate that the only one that really matters is temperature, because temperature will change the physics, the physical size of your telescope, and will move the sensor vis-a-vis the primary some little bit. If you have a carbon fiber tube, it's going to move less. Some telescopes move much more than others. Optics flex themselves. But if you are at the correct focus for your telescope and the HFR changes because the seeing changed, refocusing is not going to get you anything.
Right.
So I'll like an Oxford style debate. I'll throw that out as a proposition, and now everyone can tear it apart.
I would guess HFR is more important because, yeah, temperature changed, but how long does it take your scope to get down and equalize at that temperature? And now you're talking about, different scopes that may equalize quicker or slower. So the star size, I would think, is the most important one. It takes all of that into account and tells you what's actually happening.
Yes, but so I guess my response would be that it is over capturing, it's over triggering. It may be
too
because
often.
the scope has moved, but if it is triggering because the seeing changed, you're losing 4 minutes or
yeah.
whatever it takes, and you're going to wind up back at the same place because the new bigger diameter is at that time still going to be the bottom of the curve.
It is what it is, yeah.
Right. So I would agree, certainly early in the evening when the temperature is changing rapidly, it takes a while for a scope to settle down. But after the first couple of hours, I would think that the temperature would be a pretty good, temperature moves slowly so that the scope can catch up better and is a reasonable proxy. What do others think about it?
I got a couple comments. Um, one of the things that I think Jeff mentioned that he really doesn't have to focus a lot because his critical focus zone is pretty big. And we've been talking about the effects of temperature. So if you have a metal tube, it's going to cause the focus to change a lot more than if you have a carbon fiber tube. And the bottom line is you don't need to autofocus at all if you have a critical focus zone that's wide enough and your tube doesn't change much with the effect of temperature. So one thing that we haven't touched on much, and I think Keith may have kind of alluded to it, is that you can do a focus on a single star. You can pick a eighth magnitude star, something that doesn't saturate your sensor, zoom in on it, move the focus in and out manually, find the best focus by looking at a graph of the that particular star, and then leave it there. Okay, and in fact, I've done that for years because I have a carbon fiber Newtonian that doesn't change focus much with temperature, and if the filters are all parfocal, even though it has a critical focus zone that's fairly narrow, just by looking at a single star, you can end up getting it close to focus and locking it in there, and really only have to change focus when you go from the dead of winter to the heat of summer. Any comments on that? Anybody use single star focusing?
I kind of do, but I don't have an autofocus yet. And I use Hyperstar mostly. I've just started shooting from the back recently. And I just have a regular C8 metal tube. And I use the Bahtinov mask to focus. And it seems like, I get a medium bright star and focus on that. And as I get it really close, I mean, just right on usually. And I will check it a couple of times during the night. And my scope doesn't seem to change focus much. Sometimes I might have to tweak it just a tiny bit, but I'll come back, 4 or 5 hours later, and the temperature's dropped 20 degrees, and the Bahtinov mask is still right on. I guess my question is the Bahtinov mask just not accurate enough? And if I had an autofocuser, would that make it more accurate?
I don't think so. I think you're lucky if you have a scope that doesn't change focus very much. And again, the Bahtinov mask is using the single star focus routine. So,
right.
If you check it, even though the temperature's dropped by 5 or 10 degrees and it hasn't changed much, then you're a lucky guy. Particularly if you have a metal tube.
I always kind of consider that. Sometimes I have to tweak it, but I'm talking about, just, on the SCT, not just a tiny, tiny bit one way or the other. And I guess my question is, this is another question I have. If I get an autofocus and I'm doing Hyperstar and from the back on separate nights, will the autofocus setup be significantly different for those two? And does the ASIR allow you to save that for two different setups?
Well, if you're going from f6.3 to f2.2, yeah, your critical focus zone is going to be completely different. And it will change that.
It's like 100,000 steps. It's a crazy amount. It's very different. Using the ZWO focuser, I don't know exactly what it is, but I remember when they used to have a shorter limit on how many steps you could do. You'd have to, it was like 60,000 was the total range in the software. I'd have to go all the way to 60,000 and then say it was at 1,000 and go another 30,000 steps to switch between a Hyperstar and shooting out the back with a reducer.
Yeah, well, I get yes. When I change it, that's probably the hardest thing I do is finding the focus going from one to the other. But once you get to the other one, will the actual setup for the autofocus, in the ASIR, will it allow me to like say, okay, I want to use, I'm shooting from the back or I'm shooting a hyperstar?
No, you don't,
Yeah,
they don't
autofocus.
have profiles or the ability to say
No.
a setting for a specific scope.
Okay. Yeah, that's my question. I may still just stick with the Matinoff mask because I seem to have pretty good luck with it, but
Yeah.
now here's kind of maybe a newbie question still. What's the difference? What's the difference between HFR and FWHM? Those two terms confuse me about what's the difference.
For non-mathematicians, I would argue very little.
Okay.
HFR is half flux radius. So you have a flux, a range of brightness from the center of the star to its edge. And you're taking halfway between the center of the circle and the perimeter. FWHM, full width, half maximum, means you're measuring the full width of the star at 1/2 of its maximum. You have a cone of light now. So one is sort of, I think if one is going horizontally and one is going vertically, they're not going to be the same if you measured them simultaneously, but they're going to be within range of the same.
Okay, so the numbers will be
If
similar.
Doug Summers were here, he would tell me that I'm completely full of it. And there are huge differences and they're really important. And he'd tell us why. And he'd be right.
Because often on the ASIR, you can hit the detect button and they'll show you FWHM. And I often use that to decide if I need to check my focus. But I have noticed as the object gets higher in the sky, that tends to lower anyway because the seeing is better as you're higher.
Yes.
Yeah, and so that may not be such a great thing to use to decide if you need focus. I don't know, but
I don't think that HFR versus FWHM tells most of us anything meaningful.
okay.
So, you use whatever one's available.
Yeah, it's two different
What's
ways.
important is its relative changes more than the value between the two metrics.
Yeah, two good ways to measure star size to decide whether or not you need to refocus.
Mm-hmm.
One thing worth mentioning, I don't know, stop me if you've already covered how the ASIR focuses, but one thing I see people fretting about is the settings on the first screen, backlash, it's either fast step or slow step. It's a different step size for two different things. Those are only used for manual focusing. If you're trying to do manual focusing, the only thing the ASIR uses for automatic focus is the step size that's in the autofocus subsection of that menu. And then,
There's also an exposure setting, Craig?
huh?
Isn't there also an exposure
Oh
setting?
yeah, there's an exposure setting, but I'm talking about step sizes and backlash. So yeah, there is an exposure setting too, but the only thing it uses for autofocus is that one setting. And then what it does is it actually takes something like 4 or 5 times the step size and uses that for backlash. So it'll overstep, when it goes one direction, and then it'll come back, those 4 or 5 step size oversteps to where it starts to do the curve. And that's why you always see a decent curve. You don't see some kind of backlash involved in the curve.
Yeah,
So,
Neither just exposes that value and you can set that backlash number to whatever you want,
right.
but it's going to be in the same range.
Yeah,
But you have a backlash problem when the stepper motor moves and your star size is horizontal. A backlash problem or some other problem. Well, one comment I wanted to share tonight is I had a pattern where I always go out and I come in. So from out of focus too far away to out of focus in too close. And it would take maybe, I'll make up numbers here, but say we're at an HFR of 8, and to get down to 2-ish, which is usually my best, maybe that takes 5 steps. Then, as you get on the inside of that curve, it only takes 3 steps to get back to 8. And I go, what's going on here? Does anybody know why that curve, the hyperbola, would not be completely symmetrical? And I should say, the autofocuses are running absolutely fine. My stars are tack sharp. I just
I've
noticed
seen
that those curves are not.
sometimes where it seems to uh, almost double the step size. Every once in a while on the curve, when you notice the points and the distance going across the graph, all of a sudden it'll be like, well, I'm either missing a point that it hit and it's not showing on the graph, or it just decided to go further. So I don't know what's going on there, but I do notice this anomaly you're talking about.
I mean, I know
Jeff,
in PhD too, it can accelerate when it's coming home on a calibration, it can take 20 steps to go out and then it'll come back in 4 steps, but that's something you program because
I,
it's just
I don't know. I don't know if this is what caused your problem, but I had a very similar issue with the Williams Optics refractor and a ZWO focuser, and it turned out I thought the focuser had completely failed, and I took it off and replaced it, and I realized it wasn't the focuser. It was actually either where the focuser tightened down against the shaft wasn't had loosened, and that can be caused by temperature changes over time.
sure.
Your the little Allen screws can come a little bit loose, and also the actual tension knob that was on the Williams Optics focusing mechanism wasn't tight enough or had loosened over time, because it had been working perfectly, and then it kind of started doing that weird thing, like on the right side would be a nice curve, left side would be almost like flat and go out forever, and then it just couldn't find it. So for me, my solution to that problem was tightening both the tensioner on the focuser and the actual Allen screw that was pressing up against the shaft.
Like I said, I've had this curve as long as I've been doing astrophotography. One of the AIs says it's actually a function of your optics and the way that light refracts on the near side of focus versus the far side of focus. I have no idea.
Oh,
I say 50-50 as to whether that's right. But I had perfectly good curves. Then they started to get worse. And I had a similar problem to yours. It wasn't, the grub screws themselves had not loosened, but I had bought a used Pegasus motor focus cube, and I had used it for, I think it was 4 solid years. So it had a good amount of mileage on it, and a tiny amount of lubricant from the housing had leached out along the focuser shaft and was actually lubricating the space underneath the grub screws. So I had to take the whole thing apart and clean it with heavy duty cleaners. I refused ChatGPT's suggestion to file down one side of the focus shaft on my telescope in order to have a grub screw that would sit flat instead of seating against a round surface. But that put me back to where I was before, and now I figure every couple of years I'm just going to have to take the whole thing apart, clean it again. Do
Hey,
you
Jeff.
use a little dot of blue Loctite on those grub screws?
I don't.
Blue is the one that you can release with a little force.
Okay.
But a tiny bit with the tip of a toothpick just in the threads of the grub screw before you put it in, and it will lock the screw in place and it will not vibrate loose anymore. Don't use red though, because
Never get it off.
that's permanent.
That's a good tip. Thank you.
All right.
Hey, Jeff, I've got a question. I don't want to go down a rabbit hole, but with your filter wheel, do you refocus after every filter change, or do you have a set offset for each filter that you have previously calculated?
So I use Antlia filters, which are theoretically parfocal. Um, I have run a couple of times the Nina filter offset plugin. So it goes through 3 complete autofocus cycles for every filter. And then it averages all that data and it gives you the differential. You pick one, what's your master filter? I use red. And then it tells you, well, your HA is 32 steps this way or that way. I have used that. I actually was looking at subs not long ago and decided that my O3 was just not in focus. And the number was quite different compared to the H and the S. So I ran a couple of autofocuses and I didn't run the whole offset sequence, but I changed that number. And now, so I use one autofocus and the filter wheel runs and Nina just adjusts the focus.
All right, thanks.
It's really tedious to run that offset on 7 filters, or even on 5.
Especially if the temperature's changing.
Yes.
Okay. Any other comments or questions? All right. Well, that's good. I think everybody contributed something tonight. So thank you for jumping in and letting us know how you go about focusing. I've got just a couple of things to announce. The next meeting will be Monday, September 21st. And the topic for that meeting will be the monsoon challenge images, which you guys have all been shooting through the clouds over the last month or so.
I think right now Jim Long's row image is probably the front because it's probably an N of 1.
Yeah. So get out there and shoot your images. The monsoon actually ends on September 30th, but we're going to let you share your pictures on the 21st. And if you have a picture to share, then that picture will show up in one of the Desert Sky bulletins, either the next month or the following month. So this is your chance to get your pictures out there. Again, you have to take it during this monsoon season. You have to take the image and process it. None of this stuff from the Southern Hemisphere. So be sure.
Unless, of course, you take your rig to the Southern Hemisphere.
Unless you take your rig to the Southern Hemisphere. I'm sorry. Thank you.
Well, does Utah count as a hemisphere?
Yeah.
Cool.
Long as you do it, I don't know if you go someplace where the monsoon doesn't bother you, but I think the entire country has been kind of overtaken by heat and clouds. So pretty much anywhere is okay. So that'll be our topic for the October meeting.
Is there a sumptuous prize that goes along with the victory?
No fruit baskets.
You said
So,
October, you meant September, right, Craig?
Yeah, September. October for the Desert Sky Bulletin, hopefully.
So I have a comment that I didn't talk about early on, is that when I was pondering going to Kitt Peak to take my images of whatever I was going to take images of, I did a new light pollution map info look to see what the Bortle was on Kitt Peak. And you would expect it to be pretty low since it's the National Observatory up there. And it turns out that the 2026 version of lightpollutioninfo.org says it's 3.7 up there, which was pretty stunning that the Kitt Peak had gotten overwhelmed by light pollution. Well, the good news was I put my SQM meter up to the zenith about 2 o'clock in the morning and ran it, and it was 21.58, which equals Bortle 2. So your mileage may vary if you look at lightpollution.org. .NET 2026 version and try to find a nice dark sky. The good news was CAC was 2.4 Bortle. And if it's off by as much as Kitt Peak was, maybe we've got a Bortle 1 sky out there. What do you think?
My anecdotal impression is that light pollution info site those numbers were a huge increase over any previous data I'd ever seen.
I agree.
So I'm in Oro Valley. It says I'm Bortle 6, which I mean, I'm certainly if I look south toward the city of Tucson, it's probably even higher than that. But east and north over the mountains, I'd be surprised if it's a 6.
Well, I routinely shoot the sky whenever we do a star party, and usually I wait for there to be no moon, but I'll shoot it with the moon too, and just get a baseline of where that location was and what we can expect. So just a routine thing that I do, and sometimes I submit it to that website that where you can put your results, and I forget the name of it at this point, so I haven't submitted the one from last night, but I was stunned to see what the light pollution increase was. And if Jeff, you say that might be bad data, then I won't take it as seriously as I was I was looking around Arizona for Bortle 1 sites, and if you go kind of north of San Simon, up north of Bowie, up in that area, you can get pretty close to Bortle 2, but nothing is Bortle 1 in Arizona. Up in Utah, there was a small patch that had Bortle 1, and Death Valley was Bortle 1, and in Texas, and there's not
What
much
are
in
you
Arizona.
using for a sky meter, Jim?
I don't know the name of it. It's kind of the generic one that you buy all the time, the most common one where you just push the button and point it at the sky. It has the big red numbers on the end. It's probably the default
It's a
one.
real sky meter. You're not
Yeah.
using that sky meter app on your iPhone.
Oh, no, no, it's a real one. It's the one that you push the button and point it at the sky and it reads it. I also found out that it'll tell you the current temperature too. And that's pretty cool. I didn't realize if you push the button twice, it'll give you the temperature reading.
In the category of bad sky meters, the app Sky Meter on the Apple Store is garbage.
Yeah.
It reads way low and is useless. And the author acknowledged as much and said was going to do a new version that could be calibrated and would be much more accurate, different algorithms. So one of these days I'll have to go look and see if he ever did.
It's a unihedron is what it's called.
Okay.
It's one of the
It's
if
a
you go to
real
their website, it's the
SQL.
first one you see on their website with the missile launch button right in the middle of it. Yeah, and it has like a Bortle scale right on it that tells you what's a good Bortle and a bad Bortle. So I just keep that in my pocket all the time whenever I go and just shoot it and just to see where
Next
we're
time
at.
you're at Star Arizona, you can stay over at my house because I'm only about 7 minutes away, and you can set up your rig in my backyard, and
Shoot
you
the
can
sky.
we can see what the sky is.
Okay, that's a deal.
All
I
right.
gotta take my C11 up there. I've got a Takahashi that I'm trying to get photo capable, and things for Takahashis that weren't manufactured since 2008 are made out of unobtainium. But I found this guy in Japan that had the reducer flattener, and I have the reducer flattener, and I've just got to figure out how to connect all the pieces to an astro camera because it was really designed for a DSLR. I mean, 2007. So
Scott will take care of you.
yeah, that's what I'm going to take it up there and say, hey, make this fit here, please. And we'll figure it out.
Good
So,
luck with it.
but
Okay.
that's going to be a good traveling scope, and I'm planning to take it to the eclipse next year and to Australia in 2028. We'll see if that happens. So, fingers crossed. Thank you, guys.
All
Thanks for letting
right.
me talk so much.
Thank you, and we'll hope you see you all again next month, September, for the Monsoon Challenge images.
Thanks, everybody.
And
All
everybody.
right.
Thanks. Bye.